In this example, an air traffic controller is tracking two planes. Let's go ahead and highlight in pink the information about plane A. So plane A starts off at an altitude of 350 meters. So it's 350 meters in the air. Then eventually, plane A is losing altitude at 13 meters per second. So if I want to write an expression for the altitude of plane A, we want to begin with it was at 350 meters. So 350. Since it was losing altitude, we're going to have a subtract. And then the height of that plane is coming down 13 meters every time 1 second passes. So it was up at 350 meters, and then minus 13 meters is its new height. Then 2 seconds go by, minus 13 times 2. 3 seconds go by, 13 times 3. Since x is the number of seconds that have passed, we're going to be subtracting off 13 multiplied by x. Now let's take a look at plane B. I'm going to highlight the information about plane B in blue. So originally, plane B was at an altitude of 1,086 meters. So that's how high up in the air it is. But then it began losing altitude at 21 meters every second. So 1 second goes by and it drops 21 meters. Then another second goes by and it drops another 21 meters. So we want to have its starting height or its starting altitude, which was 1,086, and then it's losing altitude, so minus, and then we're going to take off 21 meters every second, so 21 multiplied by the number of seconds that go by. This is the altitude of plane B. Okay, lastly, we want to write an equation to show when the two planes would be at the same altitude. In other words, the height of plane A is the same as the height of plane B. Since these expressions represent the height of each plane, we just want to set the heights equal to each other. So in other words, 350 minus 13x is going to equal 1,086 minus 21x. It does not ask us to solve the equation, it just asks us to set it up.